Hi, what you just saw here is an electrical fire inside of a microwave oven. My housekeeper dropped this off here and said she saw some fire and I shall take a look on it if we can maybe repair the appliance. Yeah, electrical fire, what does that mean exactly? Electrical fires are fires which exist when electricity is flowing. So as soon we remove the electricity, typically the fire will stop if nothing else combustible caught on fire and can maintain the burning process. But every time we turn on the electricity, this will immediately ignite and burn. So what is the problem here? We are in the high voltage part of the microwave. There was a path for the high voltage to the ground, and at that path it ignited. But as you have noticed, our safeties actually here, breakers, RCD, nothing tripped. Why is that? Well, as we are here on the high voltage part of the microwave, we are behind the transformer, and this transformer is isolating the high voltage from the input, of course, from the normal mains part, and no safety device will actually see that there is a problem on this appliance here. And the only one who can prevent a fire at the end is you, who sees this and immediately turns off this, removes the plug out of the wall, and then never ever turns it on again. Okay, so let's take a look on this and then see if there is something fixable or if this should go to the trash. You can clearly see that this microwave was exposed to humidity, water probably, etc. We have dirt, we have rust inside. So here our microwave transformer and our capacitor, etc. This is the high voltage side of the microwave. So this is opposite as usually you would see in most appliances, where you take the high voltage mains down to a lower level, but in this case we are going up. We have in about 230 volts and out comes around 2000 volts AC. And so in this high voltage area, which is required by the microwave oven, our problem is located. We have our high voltage capacitor, so this one is also rated for 2100 volts. And you see that we have a burn mark here. So we have voltage jumping from our terminal to the case of the capacitor. And it is doing this via this insulator here. So this is actually a sort of plastic ring, as you can see, this one. And because I guess there's some dirt on it, grease on it, yeah, there was a path for the high voltage to find its way to the casing. And once this happened, it started burning, and then it already charred. And charcoal is a much better conductor, and every time you would now switch on the circuit, the voltage will jump over to the case and we will have electrical fire. What can we do here in this case? I have ordered a new capacitor. Even this one is perfectly fine. It still measures correct values, etc. But because this insulator there is totally trashed, this can never work anymore. And when we build in this absolutely clean new component, then it should actually work again. We'll see this in a few days. Once I get the part, we'll put this in here and then see if everything can work again. Of course, we need to clean the microwave first then, but I don't see any other problems. The electronic part, everything works. Let's just wait and see. Okay, I have just got a component delivered. It's our high voltage capacitor. And before we start working on this, let's give you a warning. These kind of devices are also sometimes referred as the widow makers. Why is that? Well, if you are planning to work on a high voltage circuit which contains a capacitor, this kind of capacitor can still hold charge. And if the capacitor, let's say inside this microwave, still holds 2000 volts, if you're going to touch one of those terminals with that kind of potential, then you might do your last repair in your life, because this sometimes can unfortunately also end deadly. So that's why never ever work on such devices if you do not know what you're expecting. So this microwave had been unplugged for 3 days. I also used these pliers and went into the terminals here, touched both sides and discharged this capacitor. So I'm going to take out the capacitor now. I actually cannot take out the capacitor just like that. There's one screw I need to open, but to reach that screw I need to remove this fan here. This fan, this PCB as well. Okay, now I can go there and reach this. So you see, it's very important if there is some voltage on this one. This here is a diode or a discharge resistor. So let's mount this one. Right, the new capacitor is in, so we can actually try the microwave again. Let's fire it up, set 5 seconds on the timer and power. Yeah, at least no fire. Everything seemed to have worked. So now we're going to get some glass of water and try to heat it up. Heat some water. 30 seconds. It's definitely doing something. There's no smoke, no fire in the back. I have cleaned out the microwave, of course, inside, blown out everything with pressurized air. So what is important is that don't let the dirt go in too much. So, do we have warm water? Yes, we have hot water. Great. Let me show you the point of failure again. So this insulator I broke by pulling out the capacitor, but on this one you can see the burn mark here, the arcs, they just ate through this plastic here and burns right through it. So quite a dangerous failure, and it only happened because there's so much dirt and probably oily stuff on this plastic that the high voltage could actually form a path through ground, and that is the very dangerous on high voltage. High voltage is a totally different animal than low voltage, so just be careful. So this would have ended up into a fire here, and if something else in the microwave could catch fire, then you have a burning appliance. So as you saw, an interesting case today, a real-time electrical fire. I never saw this in my life before. So now everything is fixed again. If there's no more dirt or stuff going into the microwave, it will still hold quite a long time again. Thank you for watching the video. Please like, comment and subscribe to the channel. I see you next time.